Okay, this is Utah Middle School Math Project 4.1D, finding and using unit rates. This is a modified version of the original task, focusing just on finding and then using unit rates to solve problems. Our last lesson was on writing equations and using equations to solve problems. Now we're going to focus on finding unit rates and using unit rates to solve problems. To get started, we have this quick poll, so pause the video so that you can write the equation for the relationship that you see here in this table. Continue the recording to check your answer. All right, and in class, the results of the quick poll went very, very well. We had only one small mistake. When we're writing equations, the first thing we want to do is find that constant of proportionality. I want to know how I'm moving forward across the table. No matter where I look, I can see that a 1 changes to a 7 by multiplying by 7. A 3 changes to a 21 by multiplying by 7. So everywhere I look in this in this table, I can see that the constant of proportionality is that we're multiplying by 7. And that includes even up here, in the labels, an x multiplied by 7 will be y, or in other words, x multiplied by 7 is equal to y, and that is our equation. In a previous lesson, we also saw that there are two equations that we can write. We can also write this in reverse order, where if I wanted to start at y and I wanted to work backwards, I would be multiplying by the fraction 1/7. The reciprocal of 7. And so you could write that backwards, saying starting in the y column, if I'm going to go backwards, I would be multiplying by 1/7, and that is going to be how I get the x. And you can see that relationship here between those two different equations. So to get started today in 4.1D, finding and using unit rates, the left-hand column gives you a description of a situation, and then asks you to find the unit rate and then to find a different unit rate. Then the other side, the right-hand column, I think I called this the right hand, that's the left hand. The right-hand column is having you reuse the unit rates that you found over here. You're reusing those unit rates to answer different questions. So to get started, I'll do the first one with you. At the store, you can get 15 cans of peaches for $3. So we want to start by finding the unit rate for $1. So when I do these problems, when I look at these problems, there are two ways that I can write the ratio. I can write 15 cans of peaches over $3, but I can also write the reciprocal and flip that and write $3 for 15 cans of peaches. So the question is, which ratio am I looking at? How am I going to figure that out based on this information? And that tells us what we need to do right here for $1. A unit rate has that 1 in the denominator. So I'm going to actually start at the end of this problem, knowing that it's going to be $1 in the denominator. And if it's dollars in the denominator, then that means that it's going to be cans in the numerator. So this is where the dollars are going to be, and up top is where the cans are going to be. So I'm going to include those labels there, so that I remember it's a ratio and not just a fraction. And now that I know that dollars, because it says for $1, that's on the bottom, that means dollars is on the bottom, cans is on the top. Now I can plug in that initial information where I have 15 cans in the numerator and I have $3 in the denominator. And now with it set up like this, we can easily say, okay, how is that 3 going to change to become a 1? You know that that 3 changes to a 1 by dividing by 3. And you also know that with ratios, whatever I do to one part of the ratio, I need to do to all the other parts. So in the bottom, I'm dividing by 3, which means in the top, I'm also going to be dividing by 3. 15 divided by 3 is equal to 5. And remember, the label for that is cans. Now this is, even though we've included labels, it still is a pretty abstract way of writing it. Normally, what I would do is I would say 5 cans for $1. That just makes it more quantitative. It's how we would actually talk in a real world situation. We would say 5 cans for $1, and we wouldn't typically write it like this. This is abstract, which is okay. This is quantitative. Part B. So obviously, based on what we just did here for part A, we know that we're going to be flipping this reciprocal. However, I want to pretend like we haven't done any of this work. How am I going to figure out what this ratio is supposed to look like? And again, the answer is right here. It says for 1 can. Remember, we want that 1 to be in the denominator. So that means the cans, which is just one single can, is 1, and that's on the denominator. So now I can work backwards and go to the beginning of that problem, realizing that then cans are going to be in the bottom, meaning the dollars are going to be on the top. And again, with that in mind, knowing that when I write this ratio, the dollars is going to be in the top or the numerator. The dollars in the original information given is 3. The cans is in the bottom or the denominator, and the cans in the original problem is 15. So now I've gone backwards, set up that original ratio, and then again I can say, okay, how does that 15 cans change to a 1 can? We do that by dividing by 15. How is this 3 changing? Well, we need to do the exact same thing that we did down below, which means we're going to be dividing by 15. Use your calculators. Your calculators here in class are going to give you a fraction, but a fraction answer here doesn't make sense because I'm dealing with dollars. So force that fraction answer into a decimal and answer appropriately. Trace, what did you get? Yeah, 0.2 for money. What does that really mean though? How would I say that quantitatively? Yeah, exactly. 0.2 for money would be 20 cents. So $0.20, 20 cents. So again, writing that answer quantitatively, I'm going to say 0.20, or you can say 20 cents. I think this is probably more useful. $0.20 or 20 cents for 1 can of peaches. Great, we found the unit rate. You've got practice and experience with that, but now again, this side, the right-hand side, parts C and D, we're reusing that same information to answer these other questions. You have $4, so how many cans of peaches can you buy? You want to stock up and buy 37 cans of peaches. How much will that cost? So again, we're reusing this information that we have already used over here. I'm going to set this up as if I hadn't already done this. Okay, because I want to show you just how useful that unit rate is. In the beginning of this problem, all I knew was that you can get 15 cans for $3. And if I'm looking for equivalent ratios here, and I'm saying, okay, I have more than $3, I have $4, so I want to know how many cans of peaches can I buy, is that an easy problem to solve? Especially if we're not using calculators here. Can you easily turn a 3 into a 4 with multiplication? Not quite as easy, right? Could you do it? Yeah. But is it something that you can do quickly and easily in your head? Probably not. And so that's why taking that baby step that we've done over here, finding that unit rate, is incredibly helpful. So we've already found that unit rate. That $3 changed to $1 with that unit rate of 5 cans for $1. We've already done this calculation, but for good note-keeping purposes, I'm going to just remind us that the $3 changed to 1, not by dividing by 5, but by dividing by 3. So I did the same thing here, and that's how I got the 5 cans. And now with that work done and out of the way, can I easily turn a $1 into the $4 that I'm needing for this particular problem? Yeah, that's easy. That 1 changes to a 4 by multiplying by 4. So I do the same thing with the other part of that ratio. We multiply by 4. Cans, 5 cans times 4 is going to be equal to 20 cans. So again, answering that question quantitatively, we can say 20 cans for $4. With that in mind, I think that we've done enough baby steps. You can work on part D on your own. So pause the recording, give it a try, and then we'll come back together and answer it together. Don't move on to the rest of them until we have talked about D, but give D a try. Pause the recording now. Ready, set, go. Okay, we're back to see how we should have done part D. And again, we can see we've already created and found that unit rate. And so where I'm asking for 37 cans of peaches, again, kind of starting at the end, I want to know how much it's going to cost if I want to buy 37 cans of peaches. I'm going to start with the ratio that has the 1 can already in the denominator. That ratio we found here over in part B, and we remember that that was 20 cents per can. So how can this 1 change easily to a 37? We simply multiply by 37, which tells me exactly what I need to do here. 20 cents times the 37 cans that I'm going to be buying is equal to, in your calculator, you're going to get 7.4. But make it quantitative, make it make sense for the problem. The unit here is dollars. So that'd be not just $7.4, it would say $7.40 for 37 cans. Okay. The next problem I really like. One day I want to travel overseas and I will be using a different money system when I go to these other countries. So this is a very relevant problem for me. Traveling between countries means exchanging currency or money. So you'll go to the exchange office, which I'm imagining is probably somewhere near the airport or something. And I have $3 and they're going to give me 2 euros. They equal the same thing. But it doesn't feel quite the same because I'm used to having $3 bills in my hand and they're only going to give me 2 of their paper euros back. So it's going to be interesting. But based on that, let's figure out, what is $1 worth? What is €1 worth? And then use that to answer these other questions. One thing that I would like to point out is this symbol right here. That symbol is for euros. Just like we have our symbol for dollars. Where is the other highlighter color? We use this symbol for our dollars. They use this E symbol with the lines going through them. It looks like an E with lines going through them. That is for euros. I'm going to pause the recording and have you guys work on this on your own first, and then we'll go over it together. So pause the recording now. Okay, we're back and we're going to get started to go over this. Again, if you're ever curious about how we need to get started on this, the clue is right here, $1. That means at the end of this problem, I want there to be 1 on the bottom and the unit is going to be dollars, which means when I go back to the beginning of the problem, dollars is what's going to be on the bottom and the euros is what's going to be on the top. So $3 at the beginning of the problem, that's the original information given, and 2 euros. And I can see that this 3 changes to a 1 by dividing by 3. And the 2 is also going to be divided by 3. 2 divided by 3, we could keep it a fraction, but again, euros are similar to dollars in that it is a currency, and so they're going to be using decimals here. And so I think it makes a little bit more sense if we round it up. 0.666 repeating is going to be that 0.67. We're going to round up there. B is going to be the reciprocal or the reverse of that, where again, the end of the problem says €1. So at the end, I want there to be a 1 on the bottom, and I want it to be referring to euros. So going back to the beginning of that problem then, that means that the euros are going to be on the bottom in the beginning, and it's the dollars that's going to be on the top. So again, 2 euros, and that's going to be $3. This time the 2 is changing to a 1, and how does a 2 change to a 1? By dividing by 2. And that 3 is also going to be divided by 2. 3 divided by 2 is equal to 1.5. Since we're dealing with money, I'm going to call that 1.50 or $1.50. Let's talk about what these mean before we go on. That means €1, you might only be holding one single euro coin or one single euro bill. I'm not sure what it is, but it is worth $1.50 of American money. Where when you hold only $1 of American money, it's worth 67 euros, 67 euro cents. I'm not sure what exactly they would call that, 0.67 euros. So now, moving on to the next problems, C and D. Suppose you take $1,450 with you on vacation, $1,450. And that's what we take to Europe, and we go to that exchange office, and how many euros are we going to get back? I'm not going to start here at the very beginning. We found the unit rate for a reason. I'm going to start here with that unit rate. So starting with knowing that it's 67.67 euros for $1, and I brought $1,450. I want to know how many euros I'm going to be carrying around with me. So how is that 1 going to be changing to a 1,450? Nice and easy, we multiply by 1,450. We're going to do the same thing here as well. Now, just to be consistent so that we don't have any issues with our rounding, when I plug this into the calculator, just so I can make sure that it's accurate, I'm actually going to plug in 2/3. Over here, I did change it to 0.67, but just for calculation purposes, I think it's going to work out a little bit better if I keep it 2/3. So 2/3 multiplied by 1,450, I end up with, and you guys can check my answers with me, I got 966.67 euros. How'd you guys do? Great. Now we go on vacation, we spend a bunch of those euros. At the end, we have 625 euros left. It doesn't make sense to bring those euros back to the United States because we can't spend euros here. They would just be sitting. So it makes more sense at the end of that vacation to transfer them back into dollars so that we can use them. So again, we're changing our euros back into dollars. How many dollars am I going to get? Start back here with that unit rate, with that one single euro on the bottom, the $1.50 on the top, and we can see how is that 1 euro going to change to 625 euros. We're going to multiply by 625. So I'm going to do the same thing up here with that $1.50. Multiply by 625. So my calculators are malfunctioning. 625 times 1.5. All right, 937.50. I'm going to end up with $937.50 back that I can take back to the United States and spend at home. All right, next set of problems. Fractions are friends, so don't be worried that we see fractions here. We're still going to handle these in the same way. So pause the video, give it a try on your own first. Students are going to work in groups here in the classroom. Then we'll come back together and go over it. Emina can walk 1/2 of a mile in 1/4 of an hour. How many miles can she walk in 1 hour? So again, starting at the end, knowing at the end of the problem, I want it to be 1 hour on the bottom, because that's how a unit rate works. I'm going to rewrite this problem with the given information, knowing that the hours are going to be on the bottom and the miles on the top. The original information was it's 1/2 of a mile in 1/4 of an hour. I now need to know, how does 1/4 of an hour change to 1 hour? And I know the standard answer is we can always change it to 1 by dividing by itself, yes. But dividing by fractions is kind of messy sometimes, especially if we're trying to do math in our head. How else can I change 1/4 of an hour into 1? What else could I do? Grant? Yeah, multiply by the reciprocal, exactly. 1/4 of an hour. If I have 4/4 of an hour, I have a full hour. So I just wanted to make sure that you can see that a little bit different way. When I have the option up here of dividing 1/2 by 1/4 or multiplying it by 4, multiplying by 4 is easier. It's something that I can do in my head. So 1/2 of a mile times 4, that ends up being 2 miles per 1 hour. Now the reverse. How long does it take her to walk 1 mile? So again, now I know that 1 mile is going to be here in the bottom, which means it's here in the bottom at the beginning of the problem. And that means hours is going to be on top this time. So 1/4 of an hour, 1/2 of a mile. This 1/2 of a mile is going to be changing to 1. And just using that same reasoning as last time, how can I change that to a 1? Yes, I can still divide by 1/2. Can be messy. But if I just multiply it by 2, 2/2 makes 1 whole. So multiply by 2. Multiply the top part of that reciprocal by 2. 1/4 times 2 ends up being 1/2 of an hour. So it'll take her 1/2 of an hour to go 1 mile, or she can go 2 miles in 1 hour. Part C and D. If Emina walked an entire marathon, that's 26.2 miles, how long would it take her to walk the entire marathon? So I'm going to start at the end of the problem. The end of the problem is 26.2 miles. Notice where I'm putting it down there in the bottom. Which unit rate am I going to be using? I'd have to use this one because it's the 1 mile that I'm changing to 26.2. I don't want to change 2 miles into that. I want to change this one. So I set this problem up differently. Can't always use going straight across. We need to use this one. So 1 mile is going to change to 26.2. Using that unit rate, 1/2 of an hour for 1 mile, and that 1 mile is changing to 26.2 by multiplying by 26.2. I'm going to do the same thing up here. 26.2 times 1/2 of an hour ends up being 13.1 hours. It's a long time. I would not recommend walking a marathon, especially at that pace. That would be an all-day event, 13.1 hours. If Yemina had a goal to walk 5 miles every day, how much time should she set aside for walking each evening? So now again, I'm starting at the end here. The end result is we want it to be 5 miles. So I'm going to choose the unit rate. That would be this one right here. Not 5 miles. Yeah, 5 miles. I'm going to choose the unit rate here that is going to change miles into miles. So 1 mile, 1/2 of an hour. And I can see here 1 mile multiplied by 5. So 1/2 of an hour multiplied by 5. And 1/2 of an hour multiplied by 5 is equal to 2.5 hours. She needs to set aside 2.5 hours every evening so that she can keep up her goal. Walking for 2.5 hours every night will have her walk 5 miles. Last problem, again, don't worry about fractions. We can always write this a little bit different. It says Napoleon earns $4.50 in 5 hours. That's a weird way to write $4.50. We normally wouldn't write $4.50 as a mixed number. We can rewrite that as 4.50 or $4.50 in 5 hours. How much does he make per hour? How long will he have to work to earn $1? Find each of those unit rates and have them help you find or answer these following questions. Pause the recording and make sure you give it a shot on your own. Okay, how much does he make per hour? Starting at the end. Per hour means that's going to be 1 hour with that 1 down there in the denominator. So going back to the beginning, hours is going to be the unit I put on the bottom, and dollars is going to be the unit that I put on the top. So that's going to be $4.50 in 5 hours, and that 5 is changing to a 1 by dividing by 5. So I'm going to do the same thing here. 4.5 divided by 5 is equal to 0.9, or in other words, 90 cents an hour. It's not too much money, not the best job, not the best pay rate, 90 cents an hour. How long will he have to work to earn $1 whole? So now again, we're starting here at the end. I've got $1 here on the bottom, which means at the start of this problem, I'm going to have dollars on the bottom of that ratio and hours at the top. Again, that's 5 hours and $4.50. That's the original problem, the information given at the beginning. And this time that 450 is changing to a 1. I can change that 450 into a 1 by dividing by 4.5, $4.50, and do the same thing to the top part of that ratio. So I have 5 divided by 4.5, and that is a repeating decimal. He would have to work 1.11 or 1.1 overbar hours to make $1. All right, let's answer parts C and D. All right, part C, Napoleon needs $37 for a new suit. So how long is he going to need to work in order to earn enough money? So starting at the end, we know that that 37 is going to be here on the bottom. And that also means that I'm going to use the unit rate here that has the $1 on the bottom, because it's very easy to change that $1 into a 37. I simply multiply by 37. And whatever is there on the top, I'm going to multiply that by 37 as well. What is on the top? Go back to that. We have our 1.1 repeating. That actually is 10/9. So I'm going to go back to the original. That is 10/9. It'll be easier to get an accurate answer that way instead of trying to worry about a repeating decimal. So 10/9 multiplied by 37. We get 41.1 overbar. So 41 hours. He's going to have to work 41 hours just to earn enough money to buy his $37 suit. And the final one, if Napoleon worked 17 hours throughout the entire week, how much money would he make? So again, starting at the end, that's 17 hours, which means I'm going to start back here with the unit rate that has 1 hour on the bottom. That 1 Our on the bottom means that we have our 90 cents on the top, $0.90. How is that 1 changing to a 17? We multiply by 17. So the same thing up here with that 90 cents, we're going to multiply that by 17. So 90 cents times 17 is going to be 15.3 or $15.30. He's going to work all week, working 17 hours and only make $15.30. All right, that is it for the lesson. The rest of this is your homework. The homework is actually a different section. It's 4.1F. It's on using unit rates to solve problems. So it's going to look different. It's going to have a different format, but it's going to be the same types of problems. Find the unit rate, use the unit rate to answer the question. That's it for today. Thanks for watching. We'll see you next time.